Hello, my dear students. Today the topic is periodic classification of element. Now, what is element? Element is the smallest atom which consists of electron, proton, and neutron. Why we need to do classification? So it becomes convenient and easy for studying their physical and chemical properties. Now, back in the history there were very less elements discovered, about 30 elements only, and the basis of their classification differs from one scientist to another scientist. Previously it was just classified on the basis of are they metal or non-metal. That means are they donating the electrons or are they receiving the electrons. So, as the research goes on and discovery of new elements started to come into pictures, different scientists have their different theory, their different way of classifying those elements. So back then only 30 elements were only classified, and for now today we have 118 elements discovered, and it is all well classified in modern periodic table that you will see further. So basically the three important classification from history we have to study. The first one is Daubernier trade, second is Newland law of octave, and Mendeleev periodic table. I repeat, Daubernier trade first, second is Newland law of octave, and third is Mendeleev periodic table. The fourth one, which is modern periodic table, that we all are agreeing to it, and we follow that periodic table, modern periodic table basically. But before that we will study these three, that why, how these all came into picture, and why we are not considering this, why they failed to impress the other scientists, and why we have discontinued this. All we will study now here. So, starting with the first classification, which was put forth by the German scientist known as Daubernier, he classified three elements in one group, and he named that group as a trade. Okay, so in one trade there were three elements, and he considered those elements to be having the same physical and chemical property. So he classified the three elements in increasing order of their atomic masses. Okay, atomic mass, atomic number, that already you have studied. I will also take this topic, but for now just remember that the basis for classification for Daubernier trade was increasing atomic mass. Sorry, it is increasing atomic mass. Okay, so he made the trade with the three element with increasing atomic mass, and he said the atomic mass of the middle element is the average of the atomic mass of the first and third element. If you see there is one a table given, and in first trade lithium, sodium, and potassium is given. Lithium atomic mass number is given 6.9, and on right side if you see, potassium is given 39.1. Now, if you take the mean or the average, 6.9 plus 39.1 by 2, it comes to 23. So, actually the atomic mass was found to be 23 only. So, it was the basic of classification he done, but then there were lots of demerit because he only classified few elements, and later on many new discoveries were coming, and this trade was not able to have justification for all the classification which was to be done, so it was discontinued. Later on, the new theory by the English scientist John Newland came into picture, and it was famous. The name he gave for its classification was Newland's law of octave. Now, what is law of octave? It is nothing but Western country, as they have the sur, like we have sare, gama, pa, dha, ni, sa. So they also have those sur. So basically, what happens? The first sur of like sa and the eighth is similar. So he also classified the element in such a way that that came like first element was showing the resemblance with the eighth element. Okay, so his classification of doing the element was also in increasing number of atomic mass. Okay, so as he was arranging the element, he found that the first element was showing the similarity, the chemical property and the physical property were coming similar to the eighth element, and so on. But still there were some problems, because as these elements were being arranged, there were new elements discovered. So where to fit them, and some elements were also placed which shows different chemical properties, but they were kept in the same group. Some elements were metal, but they were kept in non-metal group. So this was all happening. So it was not justified by then. Then came Mendeleev periodic table, the third way of classification, which was put forth by Russian scientist Mendeleev. Now, Mendeleev periodic table was the most important step in the classification of element. Why? Because by that time 63 elements were known. Okay, and he was also able to classify those elements in increasing order of their atomic masses. So till here, Mendeleev periodic table, the basis of classification was only on the atomic mass number of the element. He also made a periodic table, as you can see, on the basis of chemical and physical property of the element. Physical property, as you all know, melting point, boiling point, its density, all those things. And chemical property, if they react with some other element or some other compound, what will be the result, what are the products formed, those are considered as the chemical properties. Now he made 8 vertical columns. He called them as groups. Okay, and the horizontal rows he named it as the period. Now let's consider as the what are the advantages or the merits of the Mendeleev periodic table. Now some elements, their atomic mass was revised. It was wrongly done by other scientists. Another classification which was put forth by other scientists was revised back again. One example is given there, that was beryllium, which was previously was 14.09 was the atomic mass, but then the correct value was 9.4, so it was revised by then. He also kept some vacant place in the periodic table, so that any which the elements which were not discovered by then, it could be discovered. And he also predicted the properties, and he named those 3 elements as Ika boron, Ika aluminium, and Ika silicon. These 3 boxes were kept, and he named for temporary basis, he named them as Ika boron, Ika aluminium, and Ika silicon. Later on, it was found that scandium, gallium, and germanium. Scandium, the atomic mass was 44, gallium was 68, and germanium was 72. It was found respectively, and these elements were well matched with those predicted by the Mendeleev. So it was success back then. Now, after some time, halogens and noble gases meaning the elements which do not react with any other element, which with their electronic configuration, the outermost shell is completely fulfilled, so say they don't react with any other element. So that were also discovered, like helium, argon, all these things. So he, without disturbing the other elements, he kept them, those noble gases, in the zero group. Okay, so he made a separate group known as zero group, in which he kept the noble gases. But also there were some demerits in Mendeleev periodic table too, because if you see cobalt and nickel, okay, their atomic masses are same, but their properties were different, but still they were given the same place. So it was a demerit. Hydrogen was unsure, because hydrogen was resembling with halogen, that was chlorine, fluorine, bromine. They behave as halogen in giving rise to one electron to other element. Also they behave as a alkali. Okay, alkali meaning lithium, sodium, those group. So the problem for hydrogen was also confusing in which group it should. For isotopes also, isotopes have the same atomic number and different atomic mass number. So the places were kept same even though their mass number was different. So that was also the problem. So all these were taken into consideration and was well established in modern periodic table that you will see. Electron number of the atom and atomic number. So in Mendeleev periodic table, the atomic number in Mendeleev periodic table only indicate the serial number of the element, but it wasn't sure that that could be the most basic classification way to classify the element. So anyway, Henry Moseley in year 1930, he with the help of his experiment done by X-ray tube, he came with a result that the atomic number, which is denoted by capital Z, of an element corresponds to the positive charge on the nucleus. That means atomic number is related to the proton present in any atom. Okay, proton is present where? In the nucleus. In the nucleus, proton and neutrons are present. Okay, and outside the nucleus in the orbit, the electron revolve around the nucleus. So the negative charge, that is electron, is revolving around outside the nucleus, and the positive charge, that is proton, which is present inside the nucleus. And as you all know, neutron has no charge, it is neutral, it is not having positive or negative charge. So proton makes the positive, and electron, which is present outside the nucleus, is the negative charge. So atomic number is because of the number of protons or electron, because as you know, for a neutral element the number of positive charge and negative charge will be similar, otherwise it will have a negative or positive charge. If anything is more, like proton is more, it will have a positive charge over it. If electron is more, it will have the negative charge over it. For a neutral element, the number of electron and number of protons are same, so that is why there is no charge on that element. Now coming to this, the basis for classifying the in modern periodic table, it was the atomic number. So it was said that the properties of element are the periodic function of the atomic number. Now what are the significance of having the modern periodic table? So as I told you that back then till 63 elements were only classified, and now by this time 18 elements were known, and it was all well classified in this. Now as you know that modern periodic table is because of the increasing atomic number. By that time previously it was just the atomic mass number, but now modern periodic table is based on the atomic number of the element. Modern periodic table is also called as long form of periodic table, and the properties of elements can be predicted more accurately with the help of modern periodic table. So coming to this table, there are rows and periods. If you see, now in modern periodic table, there are 7 horizontal rows called as period, and there are 18 vertical columns. Those are named as groups. I repeat, there are 7 horizontal rows. 7 horizontal rows. They are named as periods, and there are 18 vertical columns. They are called as groups. Apart from those 7 rows or 7 periods, there are also 2 rows down. If you see, they are extra. They are first one is lanthanide and second one is actinide series. Now the entire periodic table is divided into 4 blocks. Okay, S block, P block, D block and F block. Okay, where S block consists of first and second group. The first row that you are seeing, and the second group, that is considered as S block. Okay, then is the P block, that start from 13 to 18, the right side one, and in between from 3 to 12, those are D block. Okay, D block or elements are also called as transition element. And F block, those two rows where there no down, lanthanides and actinides, those were considered as F block. So I repeat it one more time. The first two are S block. Okay, 3 to 12 are D block, and 13 to 18 are P block, and down two rows are there, those are considered as. Now you all can see a zigzag line that is drawn in the P block of the periodic table. Okay, so left side of the zigzag line is all metal, and right side is all non-metal. So in between those color different is there, no, that is all metalloid, that has the property of metal as well as non-metal. So with this we'll just keep it till here, because then we have to go into electronic configuration and all those things. So what we have studied today is what are the basis of classification of elements. So previously it was atomic mass, but now it is atomic number. Okay, we saw three way of classification that we used to follow back then. First was Daubernier trait, second was Newland law of octave, and third was Mendeleev periodic table. So there were some merits, also the demerits and disadvantages were associated with it. And as the new elements were being discovered and new research and studies were being made, scientists were coming up with the new way of classification. That's for now we have a modern periodic table, which is also known as long periodic table, and it has 118 elements which are classified into periods and groups, and also they are classified as S, P, D and F blocks. Okay, so we'll continue further. Anything important in this, I will just link some website so that you can study further. Okay, thank you.